title is of the entire chapter, as I said, it says integration, but it's way more than integration. So I'm just gonna say integration, but it's way more than that. Okay. First of all, in 4.1, I'm not presenting the sections exactly how they are presented here. You will have all the information you need, but it's not going to be exactly step by step the way they do it. It's up to you, of course, if you want to look ahead. So anyway, in 4.1, we're going to talk about antiderivatives. Antiderivatives. What are they? Well, we can be given one option is f prime, and we are asked to find the function that has this derivative. There are also two options here. If option number one, given initial, you're going to see what that means, conditions, we find a specific f of x, just one f of x. Number two, possibility two, without initial conditions, we find the most general antiderivative. Which is a family of functions. This will become very clear in the next few minutes. So if I'm given initial conditions, then I will find a specific, unique f of x. If I am not given initial conditions, I will find what it's called the most general antiderivative of function f prime, but it will be a family of functions, many functions that have the same derivative. There is a second option. If I'm given f of x, which is a function, we may be asked to find uppercase f of x, which is, by definition, the most general antiderivative. Of f of x. So now you can say, but these are the same. Sort of, yes, but the notation is different. And this is very important. So the only difference between part 2 here and the second option is the notation. Uppercase f of x. And you will see why this is important, because of the fundamental theorem of calculus. Okay. So let's talk about antiderivatives and see how we determine antiderivatives for different functions. Okay, so let's suppose I would like to determine a function whose derivative is x to the third. Well, the answer is x to the fourth over 4 plus a constant c. How come? Well, when I differentiate x to the fourth over 4, I bring down 4, subtract 1 from the power, I will simplify the 4, and I get x cubed because c prime will be 0. So in general, in order to obtain x to the n, we will have to differentiate x to the n plus 1 over n plus 1 plus a constant c. So let's look at an example and see how this works, and then we'll look at others. I'm not using the integral notation just yet in this section. I know they are using it. No, it's not the right time. But again, you can use it if you'd like. So let's suppose we are given, I'm on page 379. And let's say we want to look at 54. And we are given f prime of x equals 6x squared minus 4x plus 2. We are also told that f of 1 is 9. So the question is giving us f prime. It's giving us an initial condition. Right here, this is the initial condition. And we're asked to find a specific unique f of x. Not a family of functions, not the most general antiderivative. Not sure what's happening with my pages here. Okay. Good. So in order to find f of x, I have to ask myself what function prime will be x squared. But I have the formula right here in front of me, which states that I have to increase the power by 1 and divide by that power. Minus 4. In order to get x, I have x squared over 2. I increase the power by 1 and divide by that power. Plus, which function prime is 2? Well, it has to be 2x. And plus a constant c. So c is a constant. Okay, I will clean it up a little bit. I will say this. Yes, please.
So does c always have to be there when we do like any of these problems like these?
Yes. Let me explain why. Very good question. So at this point, I'll stop and say, when I differentiate this function, do I get that? Let's see. I bring down 3, simplify, so I have 6x squared. I bring down 2, simplifies, and I get negative 4x. I differentiate 2x and I get 2. I differentiate c and I get 0. So this right now is the most general antiderivative of that function. This is a family of function because c can be anywhere between negative infinity and infinity. These are infinitely many functions with the same derivative. But now the initial condition will make us find that specific one, just one, whose f of 1 is 9. So let's simplify it a little bit. So we have 2x to the third minus 2x squared plus 2x plus c. Knowing that f of 1 is 9, I plug in 1, 2, minus 2, plus 2, plus c. So therefore, c equals 7. The unique function with these characteristics is then f of x equals 2x cubed minus 2x squared plus 2x and plus 7. Any questions? Any questions? Okay, stop me if you have any questions, please. Okay, I would like to look at the antiderivative. So this is page 3. Which function do I differentiate to get 1 over x? Well, the answer is natural log x or absolute value. Natural log of absolute value plus a constant c. So if I have, for example, f prime of x equals, I'm making one up, 2 over x plus 1 over x squared and minus 4. And we are asked to find f of x as the most general. I did not create a initial condition here. So just find the most general antiderivative. The answer will be 2 multiplied by natural log of the absolute value of x. Why? Because when I differentiate this, I get 2 over x, as we know from last time. Now the question is, what do I do with this? We discussed this situation, and I'm going to write it as a shortcut in a minute, but for now, I'm going to write it x to negative 2. I apply the same rule as I applied for the general power rule. Same rule. I increase the power by 1, and I divide by that number. And now minus 4x, because when I differentiate negative 4x, I get 4, and plus a constant c that will never go away. This will be a family of functions. I will rewrite it as 2 natural log of the absolute value of x minus 1 over x minus 4c, minus 4x plus a constant c. This is the most general antiderivative. A family of functions, in other words. They all differ by a constant. So the constant head can be anywhere between negative infinity and infinity. So I have infinitely many functions. All these functions have this derivative, guaranteed. Questions? Okay, I would like to look at total cost from marginal cost. So this is 62 on page 379. Do you have anything for me? Any question? Okay. We are given c prime of x equals x to the third minus x. Solid rock industries determines that the marginal cost of producing the X climbing harness is given by this function. Find the total cost function. Find the total cost function, assuming that C of X is in dollars, fine, and that the fixed costs are given to us as being 6,500. So first of all, let's talk for a moment about fixed costs. Fixed costs mean when nothing is produced. So when nothing is produced, C of 0 is $6,500. It's the cost of turning on the light in the building, and so much more. Okay, the fixed cost. Okay, so how do I determine that given the marginal cost, or the derivative function, in other words? Let me push this device a little bit further. Okay. Okay, so C of x will be, which function prime is x cubed? Well, I increase the power by 1 and I divide by that number, minus. I increase the power by 1 and I divide by that number, and then plus a constant c. Not to be confused with this, let me call it c1 so it's not confused with c or c prime or anything else. But I am told that C of 0, 0, 0, C1 equals 6,500, in other words. So then the total cost function is x to the fourth over 4 minus x squared over 2 plus 6,500. Any questions, please? Okay, so let's look at one more problem before we look at something else. about areas, and so on and so forth. And then we'll come back to section 4.1 for the symbol that is used, which I think it's too early to use that symbol yet before I explain other things. Let's say 68 on page 380. It's all about efficiency of a machine operator. The rate at which a machine operator's efficiency, E, expressed as a percentage, so E is percent, changes with respect to time is given as dE over dt as 40 minus 10t. T is the number of hours the operator has been at work. So E is the efficiency, and T in hours. Find E of T. That's part A. Find E of T. Okay. Remember, this notation is the same thing with saying E prime of T is the same thing with the dE over dt. We use this notation in implicit differentiation because it's safer to use it. You don't have to use it. You can still use E prime, but I recommend this. It's safer for many reasons. So this is given to us as 40 minus 10t. In order to find E of t, I have to ask myself, with function prime is 40. Okay, so this is 40t minus 10, which function prime is t. I increase the power and I divide by that number, plus a constant c. I will simplify. If you feel comfortable, you can simplify from the beginning. You don't have to write it again. So 40t minus 5t squared plus the constant c. And now it says, find E of t given that the operator's efficiency after working 3 hours is 56. So we are told that E of 3 is 56. 56 in percent and 3 in hours. This information is given basically to help us find C. So now in the function, I will plug in 3. So this is 40 times 3 minus 5 times 9 plus C equals 56. Lazy people use calculators like me. So 56 minus 120, but plus 45. I got negative 19. So C equals negative 19. Therefore, the efficiency function of T is, in correct order, negative 5t squared plus 40t and minus 19. Okay, part B. Use the answer to part A to find the operator's efficiency after 4 hours and after 7 hours. So I'm asked to find in part B E after 4 and E after 7. So I put it in y equals, and that is negative 5x squared because we don't have t, and plus 40t and minus 19. Second and table, I plug in 4, I plug in 7. So efficiency is 61% and 16%. Any questions? Any questions? Everything okay? Anyone? Is anyone there? Anyone following? Anyone? Anyone?
So how do you
yes?
How do you enter the x values in the calculator once you get to the table?
Oh, thank you. Make sure that your table set is in independent mode for ask. In ask, because otherwise the calculator will not let you punch in the numbers you want.